Okay, here is a few examples, or here are a few examples of solving equations with logarithms. We're solving a logarithmic equation. And what you need to do is, you kind of look at this as either one of two ways here. We just have number 11 here. We're asked to, select obviously the choice. It either has an answer, simplify our answer. It doesn't say specifically how to do that. But or there might be no solution. So for this particular one here, since the base is x, what we can do is either take the exponential base x of both sides because those are inverse functions and these cancel each other out. So we'll just be left with 9, and this is just x to the negative 2 power. Or we can go back to the definition and say x to the negative 2 is equal to 9. Both of those will end us up, or end at the same place. All right. So we get that equation out of a logarithmic form by either using the definition or by using the inverse function, which is the exponential to the base x. And we're assuming, again, x is a positive number here other than 1, right? Because that's the restriction here for a logarithmic function, okay, or base of a log function. Now, once I simplify here, x to the negative 2 power is 1 over x squared. I'll just write this as a fraction. 9 over 1 cross multiply is one of the ways to solve this. So I end up with 9x squared equals 1. Divide both sides by 9. Pretty simple. Take the square root of both sides. I get plus or minus the square root of 1/9, which is plus or minus 1/3. But I ignore the negative because, again, x cannot take on a negative value here. So I just get 1/3 for my solution. So if I selected this one right here, I just exposed the answer in MyMathLab. All I would do here is just select this and type in the 1/3 using my equation editor. Okay, if I get down to 15 here, again, a little bit more complex. Okay, so notice here, I'm going to take the exponential to base 2. I could do that either by the definition. It's going to give me the same place. So I take 2 to the second power here. These cancel one another out, right? 2 raised to the log base 2. They cancel each other out because they're inverse functions. So I'm just left with 4x minus 5. So that's just 4x minus 5 equals 4. Add 5 to both sides, divide by 4, and I get 9/4. And there's my solution there. Okay. I just wanted to show you, for this particular one here, another way of going about this. And, maybe you can use this to check your solution, particularly when you're taking the test, when you have on time and that sort of thing. You can, if you want, graph the left side and the right side of this equation. So just to show you, that's what I'm doing. I put in the log of 4x minus 5 base 2, graph y equals 2, and then I want to find out where they intersect one another. So I have the red and the black graph. They intersect at, just click here, and they intersect at x equal 2.25. So is that 9/4? Well, just go ahead and type 9/4 in here into Desmos, and you're going to get 2.25. So that checks out. So this is 9/4(2). So in other words, when I substitute in 9/4 here, I'm going to get 2 for that value, and that's where those graphs will intersect. So that's just a way of verifying that that's the solution. Again, they asked me over here, if I go back to that, to just type in the simplified form of the answer. I don't know if it would have taken 2.25, but like I said, if you're given a choice, just go ahead and type in the fraction there. Okay, so there are your quick examples solving logarithmic equations.